Hi, and welcome to this webinar on building and orchestrating serverless applications on AWS with PowerShell. My name is Steve Roberts. I'm a Senior Technical Evangelist at AWS. In this session, we're going to take a brief overview of just what is AWS Lambda. It will be brief. I just want to make sure that everybody's on the same page as to what Lambda is. There's a lot of great content on the AWS website about Lambda. I encourage you to go and read the documents there. Then we'll get started with a demo, a very simple hello world type demo to show how to use PowerShell functions, how we can create them, how we can easily deploy them to Lambda. And then I'm going to finish up with two more real world examples. The first one to do with restricting IP access to load balancers, especially when those IPs ranges rotate and change. And secondly, orchestration using PowerShell based step functions. What are we going to learn in this session? Well, as I mentioned, we'll have a brief overview of what is Lambda. Secondly, we're going to be using the AWS Lambda tools for PowerShell, or AWS Lambda PS Core module, which is available on the PowerShell gallery. We're going to learn how to write and deploy a Lambda function that's written in PowerShell, how to package and deploy multiple PowerShell functions to Lambda, and how to use step functions that are written in PowerShell. So to get started, what is AWS Lambda? Well, AWS Lambda is a serverless compute environment. That means it runs your code, which we refer to as Lambda functions, without you explicitly provisioning servers. You don't need to start a VM, provision it with software, etc. You just deploy your function's code to Lambda. When your function runs, which it happens on demand, either in response to an event, for example, an S3 object getting uploaded, or it could be manually triggered from your own application code, Lambda provisions a runtime environment, downloads your function, runs the code, and then returns the payload, if there is one. This is what we call automatic request-based scaling. In other words, as the number of requests to run your function come in, Lambda provisions multiple runtime environments to run your code. Now, it may not be an exact match of one runtime environment to one request. Once your function finishes executing, Lambda holds onto your runtime environment for a short period of time and can recycle it for the next request that comes in for the same function. This means that you cannot maintain state in Lambda functions. So if you need to maintain some state, you need to find some external mechanism to do that, and then retrieve the necessary state when your function runs. But the important point is, as Lambda is taking care of the scaling for you based on the frequency of requests to run your function, you don't need to worry about provisioning more servers. That's all taken care of for you. The consequence of this is that you're only billed for compute time. When your function is idle, when it's not running, there's no charge. And again, you cannot maintain state, so if you need to do that, you need to consider some external system. Supported languages for Lambda, well, you can write Lambda functions in Java, C#, Node.js, Go, Python, and of course now PowerShell. So let's go and get our feet wet with a simple hello world example of how to get started using PowerShell and Lambda. The AWS Lambda Tools for PowerShell module is deployed to the PowerShell gallery, and we can install it very easily using install module and the module name AWS Lambda PS Core. I'm going to turn on the verbose switch just so we can see the output from the gallery install. So I'm going to allow the gallery to do the installation, and you'll see it's a very quick install. The module is actually quite small. So what commands are available to us from this module? Well, if I run get command module Lambda PS Core, you'll see there are four functions. Get AWS PowerShell Lambda template, which displays the available scaffolding templates for creating new Lambda functions, or of course you can just start with your own script. New AWS PowerShell Lambda, which creates a Lambda function from, or creates it on your local system, I should say, doesn't deploy it from a template. New PowerShell Lambda package, which we'll use later. We can use this in CI/CD setups where we want to pre-package the Lambda functions and deploy them using a different mechanism. And publish AWS PowerShell Lambda, which actually publishes your Lambda functions to Lambda itself. So to get started, let's see what templates we have available to us. And you see there are 6 or 7 basic templates, a basic bare bones script, a co-commit trigger, detect labels using image recognition, S3 event response, etc. I'm going to create a new Lambda function. So new AWS AWS PowerShell Lambda, and I'm going to select the basic template, and I'm going to call my function, let's call it shouty greeting. So this creates a folder. Inside there it writes a script called shoutygreeting.ps1. Let's go and take a look at that inside Visual Studio Code. So you'll see I have a README file inside the folder, and here's my actual Lambda function with some explanatory comments of just what a PowerShell Lambda function looks like. And you can see that when executing, $lambda input variable contains the input object to the input data, to my Lambda function. This can be a string, it can be a JSON object, PS object, etc. Whatever happens to be passed to it is transformed into a PS object that can be consumed by my function. And Lambda context, some additional information about the currently running Lambda environment if I need it. Equally importantly, the last item that you emit from your function will be returned as a result. And you can see here there's a require statement written there. This is how we include dependent modules. In this case, we will be including the AWS PowerShell .NET Core module. You can use any module that you like, as long as it's built for PowerShell 6. This is running on PowerShell Core. So what I'm going to do is just take out all of this code, and I'm going to do a very simple hello world. This is shouty, so I'll do it in capitals. And I'm going to give the Lambda function when it runs a name. So that will be included as $lambda input to my function. And that's it. That is the simplest Lambda function. Let's deploy it to Lambda now. I mentioned there was a publishing command, so let's start publish AWS PowerShell Lambda, and I'm going to give it a name. Let's call it shouty greeting, and the script file that we want to run. That's it. So now the tooling will actually package up that Lambda, that PowerShell function, with some bootstrap code to run it inside the Lambda environment, and deploy it out to Lambda. Now, to run inside Lambda, we need to select an identity and access management role. That provides both credentials to the code to run. In this case, we don't need any, but also controls what APIs, what services, and what service APIs our Lambda function can run. In this case, I'm just going to do a basic execution. So I'm going to choose a pre-can role, Lambda exec read only. That's it. Our Lambda function is created. So let's go and take a look at the new function in the Lambda console. So here I am inside the Lambda console itself. I'll refresh this view, and here's our newly deployed shouty greeting. So what I'm going to do to test this is I'm going to configure it. Save. I'll just call this hello. Create a test event. Okay, you can see my test event is selected here, so I have to click test. So now Lambda is provisioning the runtime environment, downloading my function code, and then executes it. Execution's finished. We can take a look, and there's the output from my function. Remember, the last thing in the PowerShell function that it writes is the actual output. If you use write host, that output gets captured and put into a CloudWatch logs log stream for that function. Something else to bear in mind. Okay, let's go back to the slides. So what did we learn? We saw how easy it was to use the AWS Lambda tools for PowerShell, or the so-called AWS Lambda PS Core module from the PowerShell gallery. We saw how we can explore sample blueprints and how to create new scaffolded functions using those blueprints, and how to deploy a PowerShell-based Lambda function using the publish commandlet. Let's move on to some real-world examples now. And the first one I want to look at is restricting access to load balancers. Here's the example scenario. You have a public-facing website, and you've got that behind a CloudFront distribution. Your CloudFront distribution is using either Lambda at Edge functions or some web application firewall rules that you want to ensure are applied for all users. Traffic to the application load balancer is restricted to only allow access from the CloudFront addresses to access it, not directly to the load balancer. This is shown in this diagram. You see here that the red line from the users to the load balancer is that's prohibited traffic. We want everything to come from the CloudFront distribution. Now, the CloudFront distribution is permitting AWS public IPs, with IP ranges, into the load balancer, and those can change over time. So we want a Lambda function, ideally, to automate this process, where the security groups that are controlling access to our load balanced environment update as the IP ranges change. Let's go and take a look at what this looks like inside the console right now. So here I have a CloudFormation stack. I'm in the US East 2 environment, and you can see I have two stacks. This is my Elastic Beanstalk environment, and this is the CloudFormation stack that I used to create that environment. If I go to the Elastic Beanstalk application, drill into the environment, you'll see here I have a URL. This is the URL to the load balancer. If I click that, Chrome will sit and spin for a while because there's no permitted access to the load balancer currently. In fact, the security groups that are controlling access to this application do not permit access. How do I know this? Let's go back to the CloudFormation stack, bring up the resources for this stack, and you'll see that there are a number of security groups. Global CF security group here, regional CF security group, and then a couple of others. If we take a look at the instance security group, which I believe, if the global CF security group, and we look at the inbound rules here, you'll see currently there are no rules, so no access through the security group. Likewise, the same applies to the regional security group. If I take a look at the instance security group, which is the Elastic Beanstalk default, you'll see it allows access, but only from my CloudFront distributions. And given that they're not permitting traffic, nothing is reaching the application right now. Now, why have we got two security groups controlling access through the CloudFront distribution? You could do it with just one security group. However, if you increase the default number of rules for the security group above 50, then fine. CloudFront has more than 60 IP ranges. Splitting it across two means we can do this with a simple configuration, which is preferable. Now, let's take a look at the Lambda function that's going to control these security groups for us. So here I have a real-world Lambda function. You'll see that I'm going to be requiring a dependency on our AWS PowerShell.NET Core module. And then I've written a nested function, update security group IP range, which is actually going to do the work of updating the security group IPs that are allowed. This function is called, at the end of my Lambda function here, you'll see it's calling the update security group range twice, one for the global addresses and one for regional addresses. Again, using two groups so we keep the rule count below 50. If I scroll back up and take a look at what this function is doing, you'll see it's getting the number of the CloudFront IPs using this commandlet, get AWS public IP address range. This is a built-in commandlet in the AWS tools for PowerShell. In fact, if I run it, we can see what output it gives us. Public IP address range, and you'll see there are all the public IP address ranges that are published by AWS for the various services and global regions. So this is the data that we want to take and transform into those security groups that I just showed you. So what our Lambda function does, it calls this helper function, it gets the current set of IPs, filters them down depending on whether we want the global IPs or local IPs. There's a small bug there that should say local. Then it gets the security group that we've told it that we want to update, retrieves the IP permissions from that group, the IP address ranges that can access port 80, and then just loops through and sets up the number of changes that we need to make to the security group to conform to the current IP ranges. All fairly standard PowerShell. And at the very end, it applies the changes to the security group. So let's deploy this function, and then we can run it and see our security groups update. So again, I'm going to use our publishing commandlet, but this time I'm just going to use this pre-canned script here to actually do the deployment. So you can see here's my stack name that I just showed you, which has the two security groups in it. It retrieves from there the outputs, which is the global security group ID, the regional security group ID, and the Lambda role it's running under. And you'll see here how we pass environment variables to our PowerShell function. So let's just run this to deploy out. So /deploy Lambda. And let's expand this so we see a little bit more detail coming through. So you'll see right now it's deploying, it's packaging up the PowerShell function into a temporary location, including the dependencies, in this case PowerShell.NET Core, creating my new Lambda function, and deploying the code. Cool, it's done. Let's go and check it out in the console. So inside my Lambda console here, actually go to the right region, inside my Lambda console here, I'm going to Lambda for US East 2. Here's the function I just published. And you can see it has access to CloudWatch logs and EC2 because it's going to be writing to EC2 security groups. So let's test this. And body, let's give it a name, call it test, create. So now if we run the function, Again, Lambda will provision the runtime environment, download the code, and execute it. Okay, cool. It ran. There's no output from our function. The actual changes that we need to go and take a look at are recorded in the security groups for our application. So we'll go back to the stack, to resources, and here's the global CF security group, which we'll go and access that. And we'll see this time that on the inbound controls, here are the access allowed to port 80 from the public IP addresses used by CloudFront. And similar changes happen to the local security group setting. Now what this means is that if we go to our Elastic Beanstalk application, I'm just going to shut down a couple of these tabs. Go to our public Elastic Beanstalk application, and again access the URL for the load balancer directly. This traffic should be prohibited. Okay, we did not permit access through the load balancer. However, if we go back to the stack outputs and we take the CloudFront URL, swipe that, and let's just launch that into a new tab. There's our application. So access is allowed through the IP ranges permitted by CloudFront through security groups, but you'll see that the Elastic Load Balancer is still pending. Cool, let's go back to the slides. So we're in through the example code. What did we learn? How to use a Lambda function to respond to changes in public IP ranges from AWS, ensuring that our load balancers, the ingress rules on our load balancers, are always up to date. And we can automate this process. If we subscribe to a public SNS notification that's linked below, then we can trigger our Lambda function to run automatically every time those public IP ranges change. It keeps our load balancer, security groups for our load balancers up to date. It's a great use of using Lambda. Our final example is to use orchestration using step functions. Now in this scenario, we have various sources. Let's say we have various applications that are contributing logs, or perhaps a single application, contributing logs in different formats over time. Sometimes they have been CSV files, then we perhaps adapted XML, then we moved to JSON. These log files are all being uploaded periodically to an S3 bucket, and we want to normalize into one log format. In our case, for this scenario, we're going to forward the transform log contents to CloudWatch logs. But if we could do this another way, we could send the logs to Kinesis, for example, the transform there. We're going to keep this very simple using step functions and CloudWatch logs. And I want this workflow to run automatically when a new log file arrives in S3. So let's go and take a look at the code. So the first thing that we're going to need is a state machine. And here you can see that I've defined my state machine in JSON format, and it has a number of states. The starting state is called determined log type. If I expand this, you'll see it's a task, and it runs a Lambda function, which I identify using the Amazon resource name, the ARM. The next state is to choose the transformer. So once we receive the S3 object, we're going to take a look at the file extension on that object, and we're going to choose which transformer we're going to use, CSV, XML, or JSON. Again, these are all referencing the next state, transform XML, transform CSV, etc. Down below are additional states. Again, these ones are referencing Lambda functions that we're going to deploy. In this case, the transform CSV log task. Our state machine functions themselves are written in PowerShell, and they're going to be using commandlets from our AWS PowerShell.NET Core module. So we have the relevant require statements at the top. Here's our test event log function. So you'll see here this is declared that it takes parameters Lambda input and Lambda context. We're not going to use the context, but we will use the input. And the input is going to consist of a PS object that contains the bucket name and the object key of the log file that was uploaded. You'll see that we get the extension for the log file. And then depending on what extension we get, we set up this log type variable. And the log type variable is then added as a node property onto the Lambda input itself. This is our state object that is passing through the individual step functions. So each step function gets the output from the step before. If we go to the invoke CSV log transform, remember there's an intermediate step here. We determine the log type, then we have a choose transformer, which is just a choice option inside our state machine. There's no corresponding Lambda function, and that will pass on to either our CSV transform or our XML transform or our JSON transform. The Lambda input object, you'll see it creates a temp file. It downloads the content from the log file from S3 into a temporary file, creates a new log stream for the output, parses the CSV file, and then for each entry in the CSV file, it adds an object into an events collection that it then writes to the CloudWatch log. All the remaining functions look pretty much identical. It's just how they handle the input content, be it XML or JSON. How are we going to deploy this? Well, we're going to use a serverless template. And in the serverless template, in its resources, this is a JSON format template to use the CloudFormation, which is how we deploy serverless applications. You'll see that we have this type here, AWS Lambda function, and you'll notice a handler statement that says state machine functions, blah blah, execute function. What's this? Are we using PowerShell? Well, the PowerShell Lambda support runs on top of the .NET Core 2.1 runtime. It's not a separate PowerShell runtime. These functions will all be submitted with a common bootstrap handler. It's written in C#, simple DLL, that in turn stands up the PowerShell environment in the runtime, and then executes the script. How does it know which script to run? It uses an environment variable, which is declared down here. You see that maps back to our Lambda function. We're going to create a package containing all of these Lambda functions in one go, so they'll all be zipped up together with our dependencies. And you'll notice that the S3 key field here inside the code reference is a relative file reference to the output package that we're going to build. When we use our .NET Lambda CLI extension tooling to deploy this, it's going to do two things. Firstly, it's going to substitute the S3 bucket and S3 key here with the real bucket and key location of the uploaded zip file. Secondly, and this is particularly useful, if I scroll down to the state machine entry inside my template, you'll notice that the definition string here, which should contain the state machine, is empty. The .NET Lambda CLI tooling will automatically inject our state machine into a copy of the template before deploying the application. What this allows us to do is keep the state machine in this really nice JSON format here without needing to worry about escaping the quotes, etc. Now, how does the tooling know what to do for the replacement? When you generate this project, or you can add this to the project yourself, is a lambda tools defaults.json file, and in here is a template substitutions entry that is a JSON path inside our template that is going to get replaced. So it will take the output from our state machine, automatically inject it into our template file, deploy the new package and the template, the revised template, to CloudFormation, which will stand up our stack. So let's see this in action. So we'll give ourselves a little bit more room here. And the first thing that I'm going to do, I'm going to have a little handy cheat sheet here. I have a deployment script here that deploys everything in one go, but we'll do each piece individually so we can see what's happening. I'm first going to take this command here, which is going to create our package. Remember earlier on, when we were looking at the commandlets that were inside the AWS Lambda PS Core module, there was a command called new AWS PowerShell Lambda package. This builds the zipped package containing our Lambda function or functions ready for deployment, but it doesn't actually deploy them. This output should look familiar from the publishing that we saw earlier, where we were doing a package and a publish in one step. Okay, now the output from this, if you'll notice, is the Lambda handler. This is what we saw in the template, the execute function bootstrap that's going to actually stand up the PowerShell environment and run our PowerShell function. Cool. Now all we're going to do is run our .NET Lambda CLI tooling, and we're going to use the deploy serverless command because we're deploying a template to CloudFormation. So you'll see here that it's just process of substitution, so it's already injected the state machine into a copy of our template. It's revised, so right now it's uploading the pre-packaged function zip code to S3, and it's also inside that temporary template, it's changed the values of the bucket and key to point to the uploaded content. Now it's just waiting for the change set to be reviewed. And once that's done, it'll stand up the stack containing our Lambda functions, the state machine, and all the relevant roles and artifacts that go with it. As part of standing up this as a template, I also chose to create a new log group that will contain all the logs. And we'll take a look at that. That will contain the log output as we actually upload our log files. Fantastic, our state machine is now deployed. So I need to do one other thing now. I've deployed a step function state machine, and to trigger this, I have a couple of options. I could write a CloudWatch events rule that monitors a CloudTrail log that in turn is written when an S3 object is uploaded. This is the recommended way of doing it if you want to invoke a single Lambda function. But what I'm going to do for this demo is I'm just going to use another Lambda function itself to actually trigger my workflow. So at the top here is a comment about the alternative approach using CloudWatch event rules and a link to the documentation that shows how to do this. In my case, this Lambda function instead is going to be triggered when a new object is uploaded to my S3 bucket. It's going to get that object's details, write them into a new PS object, the bucket name and key of the object that was uploaded, and then pass that as the state object to my state machine. So the first state inside that state machine is going to get a PS object with a bucket name and key. Now this is quite useful because potentially I could run different workflows depending on different objects that are uploaded to S3. Good to have options. So let's get this deployed. We'll go back to my little cheat script here, and the first thing I need to be able to deploy this is I need the ARN of the state machine, which is contained here. But I'm going to show you how to do it by looking at the outputs from the stack itself. So here's where we get the outputs, and we're going to filter through on the key that we know we need. So $state machine ARN now contains the ARN of the state machine, the Amazon resource name of the machine. Now I'm going to run our publish script that we saw earlier to publish the standalone Lambda function. Mr. Closing brace. Let me just put that back quickly. There we go. Use that again. Okay, so that's now packaging up that standalone Lambda function. This is distinct from our step functions. Publishing it to Lambda. Now again, we're going to specify a role that this standalone function is going to run under. It needs to be able to start the step functions workflow. So I've already created a role, Lambda start state machine role. You can see it number 3. So I'm just going to choose that. I could go from here and create a new role if I wanted, but I've already pre-built this one. All it does is it permits the Lambda function access to the step functions start execution API. Okay, so my Lambda function is created, so now we have our state machine ready to go, referencing our PowerShell function handlers. We have another PowerShell Lambda that is waiting to be told to run when an S3 object is uploaded. All we need to do now is actually configure the upload, and to do that I'm going to use a little helper script I've got here, configure bucket and trigger. We'll quickly skim through this, but you see what it does is it creates a new bucket. It then gets the details of the Lambda function that we want to invoke, then accesses the bucket configuration to trigger the Lambda function when a put object or object created event happens. So we'll go back to our deployment script, and we're just going to swipe this. So it's created the bucket for me called Steve Webinar Logs, and it's now configured it to receive an event. Awesome. So now let's go and quickly take a look at our state machine inside our step functions. So here is our state machine, ready to go. It's not running yet, so we need to give it some data. So let's go back to our PowerShell console, and I have some test logs available to us. They're very, very simple. If you look at test data here, here's a JSON version, for example. You can see there's a logged at or an event occurred at field, status, and some sort of message, just to give us some output. Put a single log file to start with. So let's just do write S3 object, which is how we upload to S3 from PowerShell. We give it the name of the bucket, Steve Webinar Logs, and I'm going to just point it at one of the files. Let's give it the JSON log file. The key in this case will be the actual name of the file we upload automatically. In fact, it's already done. So let's go back to our state machine, and we should see very quickly it start to run. So if we click at the execution, you can see it's inside determined log type. Input here. Here's that PS object that we constructed inside our triggering Lambda. Remember, that was the one that responded to the S3 event. It passed that state object with bucket name and key. That went through the choose transformer. It's chosen the transform JSON log. and we're done. So if we're going to take a look at the CloudWatch logs, here you can see, by the way, on the input object, notice that we have the bucket name and key still, but there's the log type that was added by the determined log type, that addition of no property. So that's how state is flowing down the step machine, the state machine. Let's go to CloudWatch logs, and we'll be able to see the output from the function. So here's all the right host information that came. It was captured automatically by our Lambda environment and written to the CloudWatch logs log stream for that function. This isn't necessarily the log data. If we go to logs, here's our log transformer log group that I created inside my template to go with the state machine, and here's the data that was in the JSON file. So that's how to use step functions with PowerShell. What did we learn? Well, it's pretty easy, right? We can use step functions, we can use a state machine that uses Lambda functions that are in PowerShell, and we can package multiple PowerShell functions in a single process, single zip file that we upload, or we can use multiple zip files. We have that choice. By using the .NET CLI extensions for Lambda, we deployed not just our pre-built PowerShell handler package to S3, but it also injected the state machine for us into the serverless template automatically. We didn't need to do any sort of grungy escaping of quotes, etc. So let's wrap up the webinar. What did we cover? Using the AWS Lambda tools for PowerShell module to create and deploy PowerShell-based Lambda functions. It's really simple, really easy, just 4 commands to use, 4 commands to learn. How to use commandlets from the AWS tools for PowerShell and other modules in Lambda functions by using a require statement. Now remember that the modules that you're using need to be based on PowerShell 6 or PowerShell Core. They're not Windows PowerShell modules. How to use step functions for orchestration of workflows triggered by events. In this case, we chose to use another Lambda function to trigger our step function, but it could equally have been done from a CloudWatch events rule, or perhaps even periodically. How to package, deploy, and reference multiple function handlers that are written in PowerShell. Some useful links for you. The AWS.NET Developer Center on the AWS home site, aws.amazon.com/net. And we have a new repository on GitHub for everything .NET on AWS. This gives various jumping off links to the repositories for our tooling, for .NET CLI extensions, etc. The Lambda tools for PowerShell module on the gallery, and a link to the .NET CLI extensions if you're curious how they work. With that, I'd like to thank you for listening.